Hello everyone, I'm Sumit Mehra from Algo Avengers. The problem statement we take is Coastal Threat Alert System. What the problem describes is that coastal areas are vital for blue carbon storage but faces threats like storm, surges, coastal erosion, pollution, and illegal activities. This problem is to build a comprehensive early warning and alerting platform that collects data from physical sensors such as tide gauges and from satellite feeds and historical records. So by all this taking input, we train our AI/ML model which should analyze the trends and detects anomalies or patterns that indicate looming threats, such as rising sea levels, algal blooms, and illegal dumping or cycloning. By this, the people living nearby the coastal areas are provided a alert message within, or we can say that before 24 hours, the cyclone, or you can say the sea level rising effect can harm them. So basically, what we done here, we made a web application in which all the criteria are to be placed and gathered by the input from the API and backend. Then we integrate it to it our front end and we display some alert messages on the people. If you are a user of our particular website and your current information such as location, mobile number, email, and anything that is correlated with the notification panel are within us, then we are ready to inform you about all the things be just 24 hours before anything can harm you from in while you are presenting in coastal area. Our web applications are not only for the users which are living nearby to the coastal areas. It is also helpful for disaster management department, coastal city governments, environment NGOs, fish focal civil defense teams, by which government can easily provide coastal police to the near areas where the harm is at the utmost priority. So let's go to our presentation to get a workflow that what we did to solve this problem. So let's talk about our PowerPoint presentation. I again introduce to my team that the Kush Agarwal, the team leader, Sumit Mehra and Lavish Yadav, and the team name is Algo Avengers. We just took the state problem of the problem coastal alert tracking system. So here we go from the PowerPoint presentation. The challenges. Basically, the challenges we faced while implementing is this, and why we are doing this and we are proposing this solution is cost vulnerability and blue carbon loss. The problem summary is frequent storms can be surges, mangroves and seagrasses loss, increased flooding, pollution degrade blue carbon, lack of real-time alerts, which causes the main thing risk to human lives. That and the second thing is economic losses environmental degradation, government challenges, and many more things which can harm even the humans, even the environment, even the government, and even a normal person live. Now let's move the next slide. That's how our system workflow can be done. We basically what we do is continuous monitoring. We continuous monitor mangroves and seagrasses using satellite drone data, calculating a mangrove score to access ecosystem Mangrove score to access ecosystem health. By mangrove score, we can easily see that which land of area is in danger. Then we move to the second point that is flood risk mapping. Our AI/ML algorithm analyze geospatial data to map flood prone areas using static GIS data, which is the static geographical data, and the mangrove score to create a vulnerability score. Basically, it's a type of scale that we implemented to show which area is in danger, and we prioritize our ML model in such a way the one with the increased vulnerability score are at our topmost priority. The third thing is blue carbon quantification. We quantify blue carbon loss from degraded coastal ecosystems. Emitted carbon is calculated from carbon per hectare, which is the value provided by our forest department in real world scenario. The fourth point is this real time early warnings. Basically, the main thing or We can say the base of our web application is we provide early information to the real user who are living nearby their areas and other things. Now let's go to the next slide, which is continuous monitoring. Basically, what we are going to present in the next slide is that how we are going to implement the four major features which are discussed just above the slides in our web application. First, this continuous monitoring of mangroves and seagrasses. What we done is in this data acquisition, ecosystem health analysis, AI-powered detection, secure data storage. In this, a high resolution image from satellites have been used. Then our AI model will give a particular output on this image, and by this a color band is initiated, that is red, yellow, green, according to the danger to that land area. Now we again move to the our next major point is mapping flood risk. That is, we collect input data collection, vulnerability score calculation, and risk classification. By these three factors, our AI model will help us to figure out which areas has to be marked yellow, which are in the more danger, and which people has to be notified. Let's move to the next slide, that is quantify blue carbon loss, which is the utmost priority of our web application, which help the society also, even the government. In this, we have the data input, then we calculate the carbon loss calculation, then we quantify the output. All of these things are for the nature, and that the thing we do, or we can say we propose by our a solution, and that's the thing which make our solution to be a sustainable solution and ready to be implemented in the real world. Let's move to the next slide, which is one of the most important R feature, that is real-time early warning for at-risk areas. When we give the color band to the particular area, the main motive of our web application is that the person who are living nearby to these coastal areas are provided real-time alerts wi- at least 12 hours ago, so that it will harm the less. We decided to give all the particular areas, or we can say location, a color band by which a normal person or normal human being can differentiate between which part, or we can say which location is in the most dangerous, the safest, or the mid at the risk level. Then we generate a alert which is forward to everyone's email, or you can say that the user who are our regular user, or we can say the person who is logging at our website. Then we simply send them alert messages, so it would help them to figure out which location can be a serious problem if they visit there. Let's now move to the next slide, which states that why our solution is scalable. Basically, it's a multi-region monitoring and modular AI model pipelines and high throughput alert system. Basically, this can be converted to the global level at more time and efforts if make and a real world scenarios or more data is used to train our particular AI model. Then we move to the next slide, that is who benefits and how. Basically, the people who are in benefit with this are communities, government authorities, and environment and climate, which is the most essential thing for all of us. And that's all about our solution. Thank you. Now let's take an overview of our website. So basically, this is the thing which we build in this. Landing page is there, which is shown that what we are going to do and what we are going for, what people we are going to serve. Then, why our work matters? There are the four reasons mentioned there below that our work is best and matters in the real world scenario. Then we come to how are the platform works. Basically, in this, how are the workflow, or we can say that the how our website integration is done is mentioned here in four different simple steps. Then let's explore our dashboard, which shows a particular region explanation about how it would be a place if you are visiting there or you are living there. So basically, this is the dashboard when a user login and it will look like this. Here we have a search location input. Basically, whenever you are, just search a location and get the real-time data scenario about that location. Here the name of the location can be displayed and the risk score, which is completely coming from our AI, which is trained on a large data set. Then our primary causes are mentioned as follows: higher end exposure increases coastal risk. Basically, this is a hint for the people who are living nearby to these areas that what is the main reason and why we should not do that. Next thing is that the earliest time. Here it is written is next 12 hours. Basically, by this, a person can hint that the 12 hours going to be something unpredictable or unbelievable in that particular area, so he she will not visit there until it is necessary. Then what we are going to send in the message of the alert format is written over there and with the color band also. So basically a person who is not reading our message actually can interrupt interrupt our message by the color code that is yellow, green and red. Then we have the actual date and time when the message is generated, and it's an acknowledge button by which a person can trigger that he she read it or not read it. Now let's hit our alert system. So basically here is a get alert button. When you press it will open a login page when you sign it and become a user. And whenever our model will figure it out that you are presenting at that location and that location is in danger, you will be notified at least 12 hours before so you can be safe and harmless, and we can say best B solution you have. Thank you. That's all from my side. A good bye from Algo Avengers team. Thank you.